Here we go. All right. So if we ever ask you to save an IGEMS file, top left-hand corner, you can click on the IGEMS menu and then go down to Save As and then Save As Support, and this will save a file with a .isf extension, and that saves a file that has all your machine and material settings. So if we're trying to duplicate a issue that you might be having, we can get all those settings and make sure everything's the same. So that's where you can find that. So first of all, I want to talk a little bit about, touched on this a little bit last time, but probably want to delve into this a little bit more here. If we go in, create a contour, and I go onto my contour command, we've got our different lead types, and then there's all these settings down here. So first of all, I wanted to show you the difference between an air lead in and a blind lead in. So these can be used for if you're doing very small holes, and basically blind lead will pierce right on the edge of the material. Air lead will give you a very, very short lead-in length. So let me go and set this up so it's going to force it to use hopefully a air lead on some of these holes here. So let's see, click on this and see what we got here. All right, so I can tell that this is going to be an air lead, and let me just check, see what the settings on that air lead are. So if I click on here, of course, I can see what the different things are as far as length of lead in and things like that. If I want to make sure it's going to go all the way around here, I can extend the overcut a bit. And if I do my multi-command again, it'll put that lead on there. So I'm just going to go ahead and generate a simulation of the code here so we can see what's happening. So click on my process, my 2D button here, and bring over my little simulator. And let's see here, zoom out a little bit so I can see where I am here. All right, so this hole here is also a blind lead. So basically what happens with the blind lead is it traverses to a point as close as it can to the edge of the part to allow it to give enough distance for it to apply its tool offset, turns on the water and the abrasive in this case, and then makes a very short move into the hole. So that's one technique that you can use if you're cutting very small holes, is to use that air start. So it traverses to a point, turns the water and the abrasive on, and then moves right in there with a very short move. The other option there is the blind lead. So if I switch this to blind, and I'll put the leads back on here again. So now I can see this has now, that little green lead-in line has now been replaced by this solid blue rapid line here. And this is there because we need to make a very short move in order to apply our tool offset to a cut. So by doing this, let me bring up our 2D code here again and go to that cut, which I believe is this one here. We'll zoom in, bring my code over here. So now what we can see is we've got a, basically does this traverse move here, so, excuse me, this traverse move here to come to this point here. And then in order to apply the tool offset, which is through the G41 move here, we do a rapid move with the tool off, but instead of doing that rapid move as a G00 like we normally do for a rapid move, we do it as a G01, which is a linear move with a feed rate applied to it. And then we can apply tool offset to that little rapid move. And then we come to the edge of the cut and then turn our water and abrasive on. So those are a couple different ways that you can add lead-ins if you have very small holes. All right, and then the other thing in here that I want to review is some of these choices down here. So placement internal, external, fairly self-explanatory, your different choices there. Over here on the left, I think one that sometimes people aren't quite sure what it's for, contours. So that when it's adding leads, you've got different choices: add new, replace existing, add new, or individual. So add new and replace existing is normally how this would be set, and that would put all the leads on the part, and if you made any changes to your lead settings, it's going to replace any existing leads. Sometimes you might get a situation where maybe for whatever reason we don't want to cut a geometry. So I don't want to actually water jet cut that for whatever reason. But then I decide I want to change some of my lead-ins. So I've gone through, I've set my toolpath how I want it, but I don't want it to add a lead into this cut-in when I add my leads again. And that's where this choice of replace existing can come in handy. Because if I choose replace existing and I change my leads to something different up here, when I go to add my leads, since I have contours set to replace existing, it's only going to replace the existing leads. It's not going to add any leads on any contours which don't currently have a toolpath on it. So that's one option there. The other option is add new. In this case, if we select add new, then when we do our multi-command, then it's only going to put leads on contours that don't currently have leads on them. So in this case here, if I click this part, it'll just put the lead on that one versus doing the add new replace existing. So you'll note here that it puts it at the end of the cut sequence. So it's because I told it to add new, it puts it to the end of the cut sequence. And then in that case, if I wanted to, which I probably would want to do, I'd want to come in, edit my toolpath, and then move this up to the appropriate location in my cut sequence. So those are choices there. Individual basically is just like if you were doing it with the single command, where you would just click on different contours to add your leads. The other two boxes down here, connect to part and collision detection. Let me set this back to where I'd normally have it here. Collision detection detects basically how close two parts are or where the edge of a part is. So of course, normally if we have collision detection, and let me actually just delete all these for right now, start from scratch. All right. So normally we'd have the collision detection box checked. We choose our multi, put our leads on there, and actually let me change that too. Did I have it as, let's check, because I was messing around with this earlier. Okay, auto, that's good. So it puts the leads up here, because obviously you can't put the lead down here because those two parts are so close together. If I come back into here and I put placement external on middle left and I do my multi-command, then so this one here can put middle left because there's nothing to the left of it, so that's not an issue. This one here puts it as close to the left as it can because obviously it can't put it in here because those parts are too close together. However, if I really want to force it to do it that way, if I uncheck the collision detection box and now I do my multi-command, now it's going to put that lead in that middle of that edge, regardless of how close or how far that other part is to that part. So that's what that collision detection box will do. So, of course, normally we would have that checked, but on rare situations, you might find that you want to uncheck that. The other box here that you've got is connect to part. So normally when you create a toolpath, the toolpath is connected to the part. And that way, if you move the part, then the toolpath moves with the part. Again, there may be rare circumstances where you want to move the toolpath in separately from the part. I've only had to do it a couple times ever, but if you do want to be able to move the toolpath, uncheck the connect to part box, and then when you add your toolpath, you'll see now you can individually either click on the part, or I can click on my toolpath, and then I can do things like move and copy and things like that. Again, it's rare that you'd ever need to do this one, but if you've ever wondered what that box is there for, that's what that is. I had one circumstance that I can think of that I used this once was I had a part like this, which was a part with some 5-axis bevel cuts in it, and I wasn't particularly happy with the way that IGEMS was adding the toolpath for these vertical cuts here on these circles. So I ended up making multiple toolpaths where I did this as a 2D toolpath. This one here I did as a 5-axis toolpath in the 3D 5-axis module. And then this one here was also a separate 2D toolpath. In the end, I ended up combining them all together into one part. So that's one rare circumstance where I found that command to be helpful. And let's go back to here. So that's a couple of those little boxes down there. And then touched on this one last time, the favorites button. So you can set up different lead types for thin material, thick material. So you want to use different lead-in types for doing circular low pressure piercing on glass or something like that, and different lead-in type for thin material, thick material, thick materials. You can set up all sorts of different lead types and give them different names and save them. And that way, if you do, this suddenly as a glass application, can come in, click on circular low pressure, all the leads are going to change to whatever those settings were, and then just makes it very easy to change your different lead types. If you ever need to change anything on those, so if I go back to say thin metal and I change something, like I change that to air instead of blind, you click on here and you want to overwrite it, you can just right click on top of it and click on save, or as you see there's also that choice there for delete. So that one's pretty helpful. So that's what I want to cover on the contour command. There's this automatic box up here at the top. There are some Lisp commands or codes in the background that we haven't really gotten into yet, as far as being able to more customize the lead type. So depending on part size and orientation, you can have like leads in different positions and things like that. But for right now, this really isn't that useful. So while it's tempting to check that box, please just leave that one unchecked. All right, let me delete these off of here for now. So next thing I wanted to get into was some of the different commands on submenu here. So if we go under the toolpath area, we've got some sometimes helpful commands down here. Holes command has a few different interesting choices. So if you hit the little pull down here, you've got different choices here. If you have a drill on your machine and you just want to drill a hole, you don't want to water jet cut it, if you choose the drilling option, click on OK. After you start the command, down here at the bottom it says select filter. And so basically if there was just like a certain size hole that you wanted to drill rather than drill and cut or cut, you can say, all right, I want to drill holes of that size. And now it's prompting me to select objects. So then if I go around and I click both these parts, it's going to find holes of that same size. And then it's going to add the drilling command to those holes. So let me just quickly take a look at the code here. So go into process, do our little 2D simulation. Let me change my machine settings and put a drill on this machine. All right, has a drill. All right. So now, if we take a look at this, we'll see we've got basically rapids to the first drill, turns the drill on, rapids to the next drill point, turns the drill on and off and such. So that's one way that that holes command can be used. Let me undo some of that here. And if we go back here, another choice is marking. That would basically just do a quick little abrasive pierce at that point. So if we do that one, similar type thing where it prompts for a filter. So again, pick a hole of whatever size you want to mark. So if you want to just make a mark and you're going to drill it off the machine later, then it would go to those points and quickly turn the water and abrasive on for half a second and then go to the next point. So again, if we look at that code, so rapids over, turns water and abrasive on for a split second, and then on to the next point. So that's that one. You can just do a circular pierce at a location. So if you want to go around, make a bunch of circular pierces, you can do that without doing the lead and actually cutting the geometry. The cutting option is creates a very nice hole, what they used to call their high quality hole option. So if we do this one and we'll again choose that hole size and click on there, what we'll see is it's going to end up going around these holes 3 times. And it does it once at a relatively high speed, and then it makes a couple passes at a slower speed. So if we come to this first one here and zoom in, so it makes the first pass at, back up a little bit, pause that, all right. So it's going to make the first pass at a relatively high speed, and it's actually offset by half the tool diameter. And then as it comes around, second time around, moves in to the proper tool offset distance, and then makes this pass at a slower speed, and then it's going to go around again at that same speed. So if you want to make a very nice looking hole, that's a nice way to do it. It's obviously going to take quite a bit longer than just doing it like you normally would, but again, makes for a very nice hole. So that's that command. So, and we'll go ahead and delete those. And I think that was all I wanted to show you in there. There's a subroutine thing that they added for one customer in particular, but the big ones in there would be the drilling, the marking, and the cutting options. Stationary would be similar to the marking one in that it would just do a stationary pierce at that location. So if you wanted to actually pierce through versus just making a light mark, if you use the stationary option, it'll use whatever number is in the material file for the delay at that point. So in this case here, comes over, turns our water and abrasive on, sits there for 15 seconds, and then turns the water and the abrasive off. So that one there, you'd pierce all the way through, with the idea of using that as a point to locate off of with the drill off the machine later. All right, then next review the open contour cuts command. So oftentimes we'll get one where people want to either cut or mark open contours on a part. So these lines here, what we consider open contours because the endpoints don't match up. So if you want to cut or mark things like that, when you create your part, click on this Other Objects button, and then select those entities. They'll show up here in the preview with the magenta lines, and then you can add toolpaths to those things. So you can either use the marking command if you just want to mark something, and if I use the single command, I can click on the line and the line I want to start at. So that would be a mark. Or if you actually want to cut it, you can use the quick command, and you can choose to do either a contour or a slit. Use the slit command, click on the single button, and click on the end of the line that you want to start at, and then that would pierce and cut across there. And then the other option in the quick area is the contour command. And for this one here, it'll apply tool offset and choose whether you want to offset to left or right, what you want for lead in, lead out lengths. And so if we just want to cut this top edge of this part here, click on what corner you want to start on. Since we told it tool on the left, we'd want to start on this end here, and we'd want to go towards this end here, and puts our tool path on there with the tool offset. Versus a slit cut. Slit cuts don't have any tool offset applied. It just goes right down the center of that tool path there. So that's the different options as far as for cutting open contours, either marking or cutting. As far as the speeds and things for marking, those are all defined in your material file. So if you go to your machine material settings and click on your edit material button, and you go to the top level of any of your materials on the AWJ tab, you've got your marking options. So you've got the choice of whether you want to use abrasive when you're marking, and then whether you want to use high pressure or low pressure. So if this box is checked, that tells IGEMS that you want to etch at full pressure. If you uncheck the box, then that'll tell IGEMS you want the pump to go to low pressure. And then you've got your speed for your marking, as well as if you want a delay when the water and the abrasive first turn on. And then, so if I set this right now for that, I want my pressure to go low, I don't want to use abrasive, and we'll take a look at what this code looks like. If your pump has the capability, you can have, we can send signals to the pump, tell the pump to go automatically into low pressure and high pressure when it sees those different flags in the IGEMS part. So if we look into our code again, so let's see, so we've got start a marking section. So we've got a code here, tell the pump to go to low pressure. There's a delay to allow the pump to get to low pressure, traverses over to where it's going to do that mark, and then does that mark at that 50 inches a minute that I had specified with only water only. Because it's M60, there's no M70, so the abrasive is not turning on for that. And then at the end of the marking section, the pump will go up to high pressure. Again, there's a delay to allow the pump to go up to high pressure, rapids over to the next point, and then starts its cutting. So if you have a pump that does not have that ability, then basically we can have it put M00s in the code at the appropriate point to stop the machine. So then the operator would go over and change the pump between low and high pressure. All right. So let's take a look at the manual command. So let me pull up a different one here. So this is kind of an interesting one that I did a couple months back. So this is a fairly small part, about 3 1/4 inches wide. If I measure this right now, we'll find that this is actually in metric. It's about 90 millimeters. So just to review, on our CAD tab here, we've got different options. So if we want to scale something, come over to here, can click on scale, or you can press S on your keyboard. I'm going to scale everything so I can draw a box around it, or I can do Control A. So one thing that you may not realize is that, if I want to scale, of course, going from millimeters to inch, 0.039, 03937, or in IGEMS, you can actually do division. So if you want to be really precise about it, I can do 1/25.4, 1 divided by 25.4, and that'll do the division for me if I want to be really precise about that conversion from millimeters to inch. All right, so what I'll do now is go ahead and create my part here. And for this application, customer didn't care so much about areas like inside this notch. They wanted this edge here to be super smooth, and the rest of it could be fairly rough. So in order to save cycle time, we were going to put these parts back to back, do a common line cut down the middle. Of course, with this little notch in here, that adds a little bit of complexity to the normal common line cut command here that we'll show you in a little bit. But that's where the manual command can come in really helpful. So what I'm going to do here is I'm going to use my mirror command, and I'm just going to mirror this part. So we'll mirror from this endpoint here in this way. Yes, keep the original. And then I'm going to move this part, my gap of my tool diameter. So if I'm using a 30 thousandths stream here, I'm going to move this part down by 30 thou. Since I have my ortho button on, I just have to move my mouse down in that direction, and it knows I want to move it down 30 thou in that direction. So if I want to confirm what that distance is, I've got my measure commands. So measure those 2 points. We're at 30 thou. That's good. All right, now we'll use our manual command. So come into here, manual. It's at the bottom here. It's prompting me select toolpath or press enter. I'm making a new toolpath, so I'm going to hit enter. Specify 0 points. That's basically where we're going to start our pierce from. So I'm going to give myself about an 1/8 inch lead in. So I'm going to right click and I'm going to say snap from this point here, and again do 1/8 of an inch. So again, I can either move my mouse to the right or I can press 0. So my start point is going to be out here. And now in this manual command box, I've got different options. If I want to rapid to a point, I can. Right now, I want to start cutting, so I click on start, and then you've got your different choices as far as the type of lead-in that you want to do. And then we're going to do our tool on our left because we're going to go along this edge going in this direction here. And if I click here, then that green line there is my lead-in, and then I can get into my actual cutting. So I can use the line command, and I've got a couple ways of doing this. And what we can do in this case here, I'm going to come down to this point here, and once I click on that point, adds that red line there for my tool path. And now I want to go around this area in here, which isn't a line. So if I hit enter, I can use this follow to option and say, all right, follow that contour over to this point here, puts my tool path in there. And now I need to jump this gap here. So I can't use follow to because there's nothing for it to follow. I can use the line command. I can just draw a line over to this point here and then hit enter. And I can use my follow to command again to go over to this point here and go around that way. And then I can go back to my line command, and I can either do a line up to here, or I could just do a line all the way over to here, which that one didn't work so well. So we're going to do an undo there. Sorry, line to this point here. And now we'll do another line over to this point here. And then I'll go back to follow to all the way over to this point here. So then it knows to go around that way, and then I'm going to do another line. I'll just do a line all the way down to here, and then do another follow to all the way over to this point here. So in that way, we're able to do this as a common cut, one pierce, cut the two parts, and then what I would do is I can use my quality command, and then I can adjust my quality based on what I want on my different edges here. So if I do my extra fine from somewhere over to here to somewhere over to here, I can go through and define all that, and then areas where it's not so important, then I can change to different quality here. So we'll do extra rough from here over to here, and things like that. So I've found this manual command to be quite helpful in situations like this where other commands might not be able to achieve what you want. The manual command, you can pretty much make it do what you need to do. And let's take a look at bridges. So there's two options that sometimes come in handy if you want to minimize the number of pierces, or you want to keep things from falling into the tank. So you can either do bridges or you can do chain cuts. So let's take a look at bridges first. So in here, when you start your bridges command, again, you've got you can define what you want to use as your initial lead-in for the outside bridge cut. Whether you want to be tool on the left, tool on the right, the amount of the gap for the bridge that you want to leave in there, geometry optimization, so it'll figure out how far it can get into a tight geometry, and then if you wanted to add tool path to these, in this case, these IDs. So if we just do it like right now, click on multi, select these parts, hit enter, and we'll go ahead and click on close. So it puts my tool path on all my inside cuts, and then because I told it to use the outside lead with tab, then these have the tab on there also. So that's a situation where you might prefer not to have put the toolpath in there using that single option, but we'll come back to that. And then, but the important thing here is you can see on the outside where it's got this this chain cut here. So it's going to pierce up here, come around, and go all the way around here. So if these are very small parts, you don't want them to fall into the tank. You can basically chain them together like this, and then later break them apart. So that's that. If we go back into here, back into bridges, so if I would prefer to have done my own normal single or my normal internal lead-in command, then I can just, of course, do it like this, and then come back, and if I go into my bridges command, uncheck the cut singles contour box, do my multi again. So then in this case here, it's going to use what I wanted for my inside leads, and then do my chain cut for my outside cut. So that's one way of doing that. And then, as I said, the other way of doing that is, let me delete these off of here. Way to achieve something similar under the modify option, you've got your chain cut command. So normally on this one, you would do your lead in, lead outs like normal. And then if you come into your modify chain, and you can choose what speed to cut going from part to part. So when it's coming from this part over to here, your cut quality you don't care so much about. You can have it go very fast between the different parts there. So click on OK. Down at the bottom, it says select parts. So I just click on somewhere on each of those parts that I want to connect, hit enter, and then hit enter again. And then what it's doing right now is you're basically telling it how you want to get from one part to the other part. So you can just use this rubber band, you can click, and it looks like by that red line that it's going to cut across that part, go to this ID here, but that's actually not what's going to happen. When I hit enter, you'll see here this will be the move that it's actually going to make, going from the OD of the first ring to the OD of the second ring. So then I could do something similar on these other ones. So I just click and then hit enter, it moves on to the next one, left click, hit enter again. So after it does those inside cuts, then it'll come pierce around and make those cuts. So let's go ahead and just do a quick little simulation on that one. And so we'll go ahead and play this here. So speed it up a little bit. So there's how it's going to go around. And does those moves at the faster speed. So now, of course, I'd probably want to optimize this path a little bit rather than coming up over here and all around like that. Then in that case, what I would probably do is, let's delete all those again, go back into my contour command, and I'd probably set this placement external to be either something like bottom middle or top middle. So then if I go ahead and put my toolpath on there, go back to modify, chain cuts again, click on the parts I want to chain together, hit enter, and now when it goes from part to part, since my lead-ins are down here at the 6 o'clock position, there'll be less rapid time, and I'm just gonna hit enter and just see what it does here. So because of the, if I gave myself a little bit of lead out, it would just come out a little bit and come across there, but that's how the chain cut can be used. So both of those commands can be used on, again, either very small parts you want to fall into the tank or very thick material you don't want to spend a lot of time piercing. You can use probably more likely the chain command than the, the bridges command on the thicker stuff, so you get those bridges close together. So the next thing we'll take a look at is common cutting. So of course that's one that's of interest a lot, especially water only. You can certainly do common line cutting for abrasive cutting. You just have to be a little bit more careful about if parts are going to be tipping up on you. So you want to make sure that the parts are going to lay flat, so they span enough grates so that the parts don't tip up and move around on you. So a couple ways to do common line cutting. You don't necessarily need the nesting package in order to do common line cutting. You can manually set up a layout. So I'm just going to go ahead and copy this over here for right now. And what I'll do here is I'm just going to use my array command, and I'm going to take this part here and I'm going to array it out. So we'll just go ahead for right now, say 5 columns. I'm going to do 1 row, or excuse me, 5 rows, 1 column, and then if I don't know my distance in Y, I can click on this little button here, and if I click 2 points on the Y, then it picks up what that distance is. And then for the spacing, I want to set that to whatever my stream width is going to be. So if I am doing this as water only, same using a 7/1000, of course that's X, that's not really going to matter. More in the Y that's going to matter, since we're gridding it out in our Y direction here. All right, so now we've got these gridded out, and again, just to double check here, make sure I plug my numbers in correctly. I got my 7/1000 gap for my stream width there. And now, of course, I can do something like, if I want to, I can use my mirror command, and I can mirror these parts back to back. And we'll mirror these from here down to here. And yes, keep the original. And then I'm going to move these parts over by 7/1000, so I've got my gap there. All right, so we've got our 7/1000 gap between all those parts. And if I go back to my cam tab, can go to toolpath and click on common, and there's different ways of doing the common cut. There's part-wise, sheet-wise. So part-wise will basically go around each part, and then sheet-wise is probably the way that most people would normally do it. I'll show you both of these. So if we do it part-wise, normally you would check this use diameter, tool diameter box, and it'll use whatever your current nozzle selection is. If you click on this little button down here, it'll show you what the current minimum distance is between parts, so you'd know that you don't want to use a 10,000th orifice on this. You want to be using a 7/1000. And then minimum length that it's going to use for common cuts. So it'll look through here and say, all right, if I don't want to cut anything shorter than whatever 6 inches, then it'll minimize that. That will make that a little bit longer there, shorter. Length of lead-in, type of piercing that you want to use. I'm going to uncheck this trim to sheet right now. We'll show you that here in a moment. All right, so then we select our parts, and let's see, I guess I didn't get that because that text is off of there. There we go. And if we zoom in here, we'll see that we've got 1 cut going down between each of those parts. And again, we'll do our little simulation here so we can see what's going to happen. So again, this is how it would do it if you chose the part-wise option, which again is, let me slow that down a little bit. Usually not the way that people are going to do it, but just so you can see what it is going to do. So basically it cuts the holes and then cuts the edges of a part and then moves on to the next one. So what people would normally want would be toolpath, common, and choose the sheet-wise option and click OK, select all that. And now it'll work its way back and forth across the entire part. So click on process again, 2D, and click on start. So now it's going to go around, do all the holes, and then it'll come back and do all the common cuts. So probably a little bit more efficient way to do it. Okay, so that's that. One of the other options under there, so that's manual. If I did have the nesting module, of course I can go into nest, and let's nest these parts onto this sheet of material here. And I'm telling it that I want 54 parts. And if I check this common line cut box down here, it'll use whatever my current tool diameter is for the spacing between the parts, and click on nest. And kind of gives me a preview with those red lines as far as areas that it might be able to common line cut. And we'll click on stop and OK. And if I go back to my common cutting, what I'm going to do on this one is the trim to sheet option. So I've set my sheet border to 0. So it's put those parts right up against the edge of the sheet. So as long as I can accurately position the sheet on the table with a fixture, or my tolerances are loose enough that it'll allow, I can come in here, and when I do the common, I'm doing my sheet-wise. If I choose the trim to sheet option and click on OK, drag a box around this, it's not going to do those cuts along the edge of the sheet. It'll just use that raw edge of the sheet for those edges. So this can be, again, a big time saver if your tolerances can allow it. So if we click back up here and do our preview again, just so you can see this one. So you can kind of see here already that there's no tool path along those edges. So it's going to go around, do all that, and then do all the cuts, the straight cuts. And then the other option that's in there, which I've found rare instance to use, go into common, they've got the lines option. So this will basically make CAD lines that you could then copy if you want to create a DXF file, bring it out to another software package or something. So basically what it did there was, rather than creating a sort of tool path, it just makes the CAD lines for that common tool path. And then, as I say, you could copy that, make a DXF file if you want to bring it into another CAD package or something. I said I haven't really found myself a lot of use for that, but that is available. That's what that lines option is there. So those are that's the common cut command. And let's see, let me go back to, yes, we'll go back to this one here for a moment. One question that sometimes comes up is how you would put multiple tabs on a part. So of course, if we just want a single tab on our part, we can choose, I can set up a lead that's got a tab at the lead in, lead out point, and that's all well and good. I've got a tab there, but what if you want, it's a bigger part and you need multiple tabs? Under the modify area, you have this choice from micro joints. And when you start this command, you can choose, you can set up all sorts of different lead-in types for this one here, like we do for our normal lead-in command. And you can click on this and define them how you want those to be. And then you can use your insert command, and then you can just click and you can have as many different leads on a part or tabs on a part as you would want. So that's quite useful. If you want to get rid of those, then you can use your remove command and get rid of them. Let's see, another one that sometimes comes in handy is join splits. If you go to this part submenu, you've got some different options down here, join and split. Say these parts here are part of a kit, and when you're nesting, you want to make sure that they don't get split up and you get the proper quantities of each part. So, you really need 2 of these and 1 of those and 1 of those to make the kit. If we go ahead and recreate our part, then right now these are all individual parts, and we go to nest them, they could get moved around and maybe put onto different sheets for nesting. If you go with the part, you can use the join command and you can join these together as one part. So it prompts you down at the bottom to select the part, so you can pick one part as being like the primary part, and then once you've selected one, then it prompts you to select parts, so then you can select the other parts, and now these are one part. And so if you go to nest that or do anything with that, they're all joined together. If you then later want to break them apart, then that's why you've got the split command, and then that would bring them back to their individual parts. And under this part area here, there's a couple other choices that at least a couple of that are useful for what we're talking about. Properties, of course, you can click onto here, click on your part. You can define things like how many parts you want. You can change the name, things like that. Define rotation. So when you do nest this part, if you always want to limit rotation, you can go in there. You can modify things like that. Summary tab gives you information as far as the length of lines that are in the part, things like that. So there's some useful information in there. The other thing that's on that submenu that's can be helpful is this part browser, which is here, or if you've got the nesting tab, it's also here. So if we go back to this one here, click on part browser, and it'll show you, in this case, all the different parts that are currently in my workspace. These parts have been nested, so it's showing me that it's nested 4 out of 10 of those. If you click on the part, it'll show you where that part is, so you can see where they are. Right now, the view all box is checked, so it's showing all the parts. If I uncheck this box, it'll only show me parts that have not been completely nested, so I'd see that I need to nest more of those parts there. If I click on the cleanup drawing button, then it'll delete off all of the parts that have been nested, just leaving me with the parts that haven't been nested. So that can be helpful if you're doing a lot of nesting with a lot of parts. You can see where different things are. The other thing that you can do is if you've got another drawing open that's got the same material, same thickness, if you go on the import area, then you can see. So if you wanted to then put these parts also into this job, then you can just double click on it and put it into your workspace. And if you wanted to nest that, so you can just again double click on it and click where you want that to be. So that's that screen there. So that can be helpful. And let's see, show you here. I talked about this one last time, but just wanted to review this one because it can be helpful. Is if you do want to create a template. So if I do a new workspace, again, normally, like when you first install IGEMS, you go into dimension styles. Normally, things like decimal places will be set to 2, and text height and things like that might not be how you want them to be. You can go through here, set up your dimensions and things, how you want them to be, and then you can save a template. And then also what I'm going to do here is I'm going to bring in a title block. So I'm just going to drag in a DXF file that I've got set up as what I want to use as a title block. I want to use this every time. So once you've got all your settings the way you like it, you can go up to the IGEMS menu up here, go down to Save As, and then Save As Template, and then you can give it a name. All right, so that's now been saved as a template. And then if you go again up to the IGEMS menu and then New and go into Templates, it'll show you a listing of all the different templates that you've created. So if you then want to use one of these as a default, you can select it and then click on the little star button here, and then when I do a new drawing, it's going to use that as my template. So now if I go ahead and close this, and I come in here and click on new, so now it's using that template, and then again it'll revert to whatever things I had saved in my dimension style and things like that. So that can be fairly helpful. And then finally, just want to show a couple little things on machine settings. Let's go into, oh, it doesn't really matter which one. Let's do, sure, this one here. All right. So if we go into our process area, over here on the right, you've got different settings. So cutting parameters, these are the different variables that IGEMS is using when it's creating the, when it's calculating feed rates. So if you find that maybe IGEMS feed rates are maybe too conservative, or if they're too aggressive, you can come in here and you can adjust your pump pressure or your abrasive flow rate or your abrasive quality numbers. And as you change these, your feed rates will automatically change. So if you run your pump at a little bit lower pressure, you can type in a different number there, and then that's what it'll use to, amongst all these other numbers, to calculate your feed rates for your different materials. I'll put that back where I had it. So that one is the cutting parameters. If you if you're starting to use a different size nozzle, you can click on the plus button and you can add in different size nozzle depending on what you're using. So I've got some of my common configurations here. And then under the strategy area, a lot of things in here that control how the machine acts. If you have a machine that has CNC control of the Z-axis, you can have it do things like move up and down between cuts. And to actually make it do that, if you go into the cutting area, then you have options here to lift the axis between cuts and lift the axis between parts. And you can either tell it, no, don't do that, no, but ask me, or yes, but ask. So if we have it set to no, but ask, and we've got these values in here, then that's what it'll use if I tell it that I do want to lift between cuts. So we click on OK, I go to create my CNC file, and I've got this little box here, and I've got the choices. So if I do want to lift between cuts and between parts, I can check those boxes. And then when it creates that CNC file, then we'll have our codes in here to lift. So we're lifting, let's see here, we should lift 2 inches at the beginning of the part, comes over, does its marking and such, and then lifting 1 inch between the different cuts. And then at the end of the program, lifts 2 inches. So there's also the settings in there for switching between the low and high pressure. So if we go into various, then you've got things like skip pressure changes. So if you wanted to handle all those pressure changes on the pump manually, you could just set it to no or no but ask. If you, or excuse me, you'd set it to yes or yes but ask. But if you want us to actually put the codes in there, set it to no or no but ask, and then it will put in those codes to switch the pump around. So there's a lot of interesting things in this settings area that you can use to adjust, for example, output, where it's going to be sending your CNC file. If you want to make a backup either locally or somewhere on your network, you can choose to do that. View output file, no. If you set this to yes, when you create your file, then it's going to give you, actually not the preview, actually let me go ahead and actually create the file. And sure, it'll do that little scroll by where it'll give you that little preview here, which for short files is fine, but sometimes when you get into really large files, it can take a little bit for that to all scroll by. So normally I've got that set to no. And then things like if you want to put comments into your CNC file, so if you want to know what all the different codes are, it'll put that stuff in there. So we're running towards the end of our time here. If anybody's got any questions, you can let me know. Hopefully this has been, again, informative for you. Next month we'll be doing bevel cutting using the 3D5X and the 2D5X modules. So if you're interested in seeing how 5-axis programming works, join us next month, and we'll be sending out an email again. So we'll be shooting for the, again, third Thursday. So we'll be looking at doing this on December 21st. So let's see. Oh, yes. Where can we, so yeah, I'll be uploading this, and so you can either go to our website, so you can go to wardjet.com, and you can go to support and IGEMS training, and you can scroll down. And again, this was last month's webinar. There's also shorter videos. If there's just one thing in particular that you want to see, you should be able to find it here in this basics area. So probably end of today or early next week, this webinar will show up probably under this advanced area. Or if you just go to YouTube, and for last month's, it would have been IGEMS Basics. This month's will be something like Advanced 2D. So, but we'll also be sending out a link in an email to everybody so that you can have that link and forward that on. Okay, if you don't need any piercing time, so that's going to be controlled by in your machine settings and things like that. It's two areas that control piercing time. It's going to be in machine settings and material settings. So assuming that we're doing this as a water-only application, let me go back to this one here. All right, so say this is a water-only application, which it looks like it'd probably be a good one. And if I go in right here right now and see what we've got for delays, so I've got like a half-second delay after the water turns on, half-second delay after the water turns off. So if I want to no delays, two areas to look. The machine settings, you'd click on your machine and you would go down to your cutting equipment area, and you've got delays here for delays after piercing, after cutting. So you could zero those out. And then the other place you would want to look is on your actual material. So if you click into here, and let me expand this out a little bit. Let me just go ahead and group this by groups here. And what was this? 540. So if I come to this material here, I've also got piercing time here. So if I also zero that out and click on OK and OK, click on process. So now I've just got the water on code and 0-second delay. And I'll give it another couple minutes here if anybody else has any questions that you want to type in. And if you do have any ideas for any topics you want to see in the future, you can feel free to email us. And hopefully these have been somewhat informative for you. So. Parts with multiple quality types. Let's see. I guess if you could have a comment. Other issue we're having is on parts with multiple quality types. If you could expand on that, I can see what I can show you. So if we have, I'll just go ahead and start making up a part here. All right. So if I go ahead and I create a part, yes, next month we'll be doing 5-axis stuff. So join us December 21st for that one. Slow down the corners, multiple speeds. Yeah. Yeah. So if I go ahead and I create a part. Now, if you're doing water only, things are a little bit different. But I have been able to tweak the post for customers doing water only, where they could have different speeds on a part. So for abrasive, of course, we would create our part, and when we add our toolpath, we can go through and use our quality button, and I can say, all right, I want to do these different things as, so I want to do this as a different speed. If it's water only, it's usually going to be a fixed speed thing. So if we go into water only, we're usually using, let's see, let me group by thicknesses here. We're usually using the fixed speed option here. So regardless of whether I do the different qualities here as a water only part, it's going to end up doing this all at 50 inches a minute. So let's see, get around to that cut here that we had that. So that was pretty fast. Try that again. Let's see, was it this cut here? So even though I told it a different quality, it's still at 50 inches a minute. But yeah, what I did for another customer who was water only was basically adjusted the post and said, all right, if you flag it as being a different quality, then it can use either this high speed or this low speed. And I don't know if this post that I have right now will allow me to do that. Let me see, I think it might. So if I flag the outside as being extra rough, let's see what we do here. So in this case here, yeah, so it's doing everything as 50 inches a minute except for the outside where it's doing it as 200 inches a minute. And that was because in the post I told it that if it sees something that's flagged as being extra rough, to then in the material file use whatever is defined as the high speed. So I think I did something similar where if they defined it as being extra fine, then it would use whatever was the low speed in that material setting. So if you want to shoot me an email after this, I could probably set you up with the same type post. So yeah, here we see this one here. This is doing 25 inches a minute and 50 inches a minute and 200 inches a minute. So. Let's see. What about rapids? What would you like to know about rapids? How to adjust them? Perhaps, yeah. So if we go in and like rapids on a part, if you want to change your rapids on a part, you can click on the edit button, you can click on here, and you can basically, down here, you've got the choice for rapids. So if going from, hole 1 to hole 2, there's a clamp or something in the way, you can click on this rapid button down here, and you can click and change that rapid position. So that would be like within a part, you can change them like that. So if going from 4 to 5, again, we wanted to change that one, we would click on 5, click on rapid. I guess I got that one backwards, 3 to 4. Let's see, going from that one to that one, rapid. And again, you can just click wherever you want it to go. So that's within a part. If you nest a bunch of parts and you want to change the rapid going from part to part, then that's done through the order 1, 2, 3 button up here. So let me go back to my my nesting demo version here, and let me put some toolpaths on here. All right, so if I do my order 1, 2, 3, and then so to go change your rapids going from part to part, that's done through the order button. So the start rapid would be for that initial rapid coming from where you start. So, you've got a clamp here, something you want to avoid, click on start rapids and you can change that one. If you want to change going from part to part again, so going from, in this case, this part down to this part, you want to change that rapid, you can click on rapids and click and change it. Hopefully that answers that question. Good. All right, we're at 2 o'clock. So again, thank you for your time and have a great weekend and hopefully see you next month.